Okay, we'll go for the module 5 numericals now. So that starts with the DA converter and then goes on to AD converter and so on. We have first the 8.14. 8.14 is here referring to the DA converter with binary weighted resistor shown in the figure. 8.188 determine the size of each step if RF is equal to 1.2 kilo ohm. What is the output voltage when the input B0 through B3 are 5 volts? Okay, so we need to find the size of each step if RF is equal to 1.2 kilo ohm. What is the output voltage when the input is all V0 to V3 equal to 5 volts? So 8.18A, right? 8.18A. So this is the figure which we have here, 8.18A. This is the DA converter, which is known as the, binary weighted resistor, uh, you know, uh, DAC. Okay. So that is because R by 2, R by 4, R by 8, and we'll have such resistors over here for the what you call binary weighted. Okay, we'll have full range of values. So if say something like R by 8 is something like really speaking, you can say R is 1 megohm. This will be half of megohm. This is 1/4 of megohm. This is point or 0.125 or 1/8 of the megohm. So range of values of resistors needed will be too much. Okay, from say 1/8 till the 1 megohm. Say similarly, if you have say this is a 4-bit DAC. If you have an 8-bit DAC, that will be R by 2, R by 2 square, R by 2 cube, R by 2 to the power of 4. Similarly, R by 2 to the power of n minus 1, where n is the number of bits associated with it. So that will be 2 to the power of 7, R by 128. So if this is 1 megohm, that will be 1 megohm divided by 128 will be the value of the resistor. Such will be the variation of the resistors which you need for the weighted, resistor, what you call weighted resistor DAC. Okay, so for this, let us see the formula for the step size. Step size is basically referring to something like this. Okay, so step size is basically referring to something like this. So where do we have here? B3 is the most significant bit, B2 is next, B1 is next, and B0 is this. So least significant bit, step size always is associated with the least significant bit. So if this is connected to 5 volts, if this is connected to 5 volts, this is at ground, so then naturally this will be at virtual ground. Okay, this value of the R is 10 kilo ohm, 5 volts by 10 kilo ohms. 5 volts by 10 kilo ohms will give 0.5 milliamperes. That 0.5 milliamperes, none will flow through this because input impedance of the op amp is very high. That's why all the current will flow through this. So that value 0.5 will be multiplied with this and we'll get a negative value corresponding because this is an inverting amplifier. So that is 1 kilo ohm into 0.5 multiplied by -1 or minus of 0.5 milliamperes into 0.5 milliamperes into 1 kilo ohm, that will give minus 0.5. Now the only difference in the numerical which is given to us is RF is equal to 1.2 kilo ohm. 1.2 kilo ohm. So if the RF is equal to 1.2 kilo ohm, then the value of the step voltage corresponding to this will become 0.5 milliamperes into 1.2 kilo ohm. That will give 0.6 as the step. 0.6 as the step. Step you should not write in terms of negative. Step always you should write in terms of positive value. So step value will be 0.6 in place of 0.5 because we need to multiply 1.2 divided by 0.5. So if R value is given to us, if R value is given to us and V reference is given to us, right? This is the V reference value, which is 5 volts. V reference divided by R multiplied by RF will give you the step size. V reference divided by R multiplied by RF will give you the step size. So formula for the step size is V reference divided by R multiplied by RF. Okay, so just remember that, and naturally that step size should be multiplied with a minus sign, and then with the whatever value we have uh, to get the final thing over there. So next, what do we have here? What is the output voltage when the input B0 through B3 are 5 volts? So B3, B2, B1, B0 will be all 1, 1, 1, 1. So you should write B3, B2, B1, B0 equal to 1, 1, 1, 1 to base 2. Okay, 4 ones to base 2, that is equal to 15 to base 10. Okay, if you have taken a pen and a paper, please write there. B3, B2, B1, B0 equal to 1, 1, 1, 1 to base 2. That is equal to 15 to base 10. You have to convert the binary into the, what you call, decimal. I hope you know how to convert the binary into the decimal. 1, 1, 1, 1 to base 2 will be equal to 15. That is because we need to write 1 into 2 to the power of 3 plus 1 into 2 to the power of 2 plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. Weight of each of B0, B1, B2, B3 will be 2 to the power of 1, 0, 1, 2 to the power of 0, 1, 2, 3. Whatever, powers will vary depending upon which is the value, B0 or B1 or B2 or B3. Right? So in this case, it will be 1, 1, 1, 1 to base 2. That will be equal to 15. So that 15 has to be multiplied with, minus 0.6 now, minus V refer, the step size. Okay, minus the step size. That will be 15 into minus 0.5, minus 0.6 will be, 9 volts. That will be 9 volts. For this value, it will be minus 9 volts, minus 9 volts, right? So you can see that the, values are going negative over here. In this, this is the step size. Step size means difference between, 0 value and the first step, or you can say step size is anywhere, in between. Okay, so here the step size is 0.5, where now in our problem we have the step size is 0.6. So therefore here the 0.5 into 15 will give minus 7.5, that is the maximum possible. In our case, 0.6 into 15 will be what we call minus 9 volts with a minus sign there. Minus 9 volt, that will be the maximum. And that is the answer for the question over there. Similarly, 8.15. So now we have here the next problem, which is RF equal to 100 ohms. Here it was RF equal to 1.2 kilo ohm. Now we have RF equal to 100 ohms. All other things remaining same. That is R, what you call, the value of R is 10K, V reference is 5 volts, and so step size will be equal to V reference divided by R, that is 5 divided by 10K. 10K is 10,000 multiplied by RF. V reference divided by R into RF, that will be the step size. And here we need to multiply by 100 ohms. So that will give us the value, which will be 0.05, milliampere, I think might be, it will be millivolts, is it? Millivolts. So 5 divided by 10K multiplied by the, what you call, 100 will give you 0.05 volts, sorry, 0.05 volts in place of 0.5. So 0.05 volts, right? That will be the value. And again, the what you call output voltage corresponding to V0 to V3 at 5 volts will give 1111. That will be 2 base 2. That is again 15. 15 multiplied by 0.05 will give you, with a minus sign again, minus of 0.05 multiplied by 15 will give minus of 0.75 volts. Minus of 0.75 volts. Okay, I might do some mistakes also. If I do, please correct. And if in some video there is a mistake, please inform me. Okay. So that will be the answer for 8.15. Now let us go for 8.16. Referring to the circuit of 8.18a, again same thing, determine the output voltage if B0, B2 is equal to 0 and B1, B3 is equal to 5 volts. So now B3, B2, B1, B0 will be how much in terms of binary? Please write down in the chat. In terms of binary, how much it will be? I want it in the binary format. Binary format, B3, B2, B1, B0. B2 is 0. Yes. So that's why don't be in a hurry. B2, B3 is 1, B2 is 0, B1 is 0, B1 is 1, and B0 is 0. So that's why it will be 1010. So 1010 is 10, right? 10 is 10, right? So therefore, the value of the output voltage in the case of the in the 8.14 case, right? In the 8.14 case, that will give us the value we should consider, for 8.18a, and we should consider 8.14 case, that is 1.2 kilo ohms. Or you can consider whatever you want. Might be here he has not made it very clear how much to consider, right? So might be is referring to exactly the value of 8.18a. So that is RF equal to 1 kilo ohm. So in that case, you need to multiply the step size with the value of 10 to get the output voltage. Okay, whatever the step size. In the 8.18, the step size is minus 0.5 into 10 will give you the value which is minus 5 volts. If you consider RF for this problem, minus RF equal to 1.2 steps, the step size will be step size will be 0.6 volts. Therefore, the output will be minus 0.6 into 10. That will be 6 volts. In the case of this, it will be 100 ohms. If you take, then that will be 0.05 into 10. That is minus 0.5 volts. Okay, each case separately. Now, I hope the answer is very clear from this. Then let us go to the 8.17. For the DA converter using an R to R ladder network shown in the figure 8.919a, determine the size of each step if RF is equal to 27 kilo ohms. Okay, so and calculate the output voltage when the input B0, B1, B2, B3 are at 5 volts. So again, B3, B2, B1, B0 is 1111. 1111, that is to base 2, that is equal to 15 to base 10. Okay, 15 to base 10. Okay, 1111 to base 2, that is 15 to base 10. You're right. Okay. So then what is the advantage of the type of DA converter over the one with the binary weighted resistor? That is what he's telling. So 8.19. So this is 8.19. R to R ladder network means we have only two types of resistors in the ladder, either R or to R. So if you see the earlier figure, here we have resistors which are R by 2, R by 4, R by 8, R by 16, R by 32, R by 64, R by 128, depending upon the number of bits the DAC is off. Okay, whereas in the next figure, whatever is the what you call number of bits we have in the resistors, only R and 2R resistors in the ladder. Okay, this is the ladder, and we have only R and 2R resistors. But there it was, variation of resistors is very high. Thus, that itself is the disadvantage of the weighted resistor, and that is the advantage of the R to R ladder network. Okay, because we don't, we don't want many variation of resistors. If you have a lot of variation, then the value of the current will be too low at one resistor and too high at another resistor. Whereas here it might not be the case. Current flowing through all the resistors will be, almost either half of the double of that. Fine. So accuracy will be better for this over here. So for this, we need to find the step size, right? So again, so here you can see that it is the, if you see here, B3 is here, B2 is here, B1 is here, and B0 is here, right? B3, B2, B1, and B0. So for B3 over here, for B3 over here, he has put it the value over here. So for B3, this is grounded, whatever current is there, this current is going to flow like this. None of the current will flow through this because this is, so to say, grounded. All the current should flow over here, right? Whatever is the current over here should flow over here, right? And then we should find out the value. So 20, 20 and 5 volts will give higher a minus 5 volts in this case. So please remember that B3 here is the most significant bit. B3 is here the most significant bit. So for the most significant bit, you're going to get the value which is minus 5 volts. Most significant bit, you are going to get the 5 volts. Most significant bit equal to 1 will give us the value which is, all the others are here grounded, only this is connected to the 5 volts. So this will be 10000. 1000 to base 2 will be naturally how much to base 10? 1000 to base 2 will be how much to base 10? 8, right? So that will be 8. So for the least significant bit B0, for the least significant bit B0, the output will become minus 5 by 8. With just B0 equal to 1, it will be 0001, that will be equal to 1. With just B3 equal to 1, it will be 1000, that is 8. So therefore, if the voltage is for B3, if the voltage is minus 5 volts, for just B1, the voltage, output voltage will be 5 by 8, minus 5 by 8. Minus 5 by 8 will give us the step size, which will be minus 0.625. Minus 0.625 will be the step size over here. So you can see that steps are in the form of minus 625. So minus 625, you can just go on, writing like that, and then might be, because it is 4-bit, okay, 4-bit means you can multiply it by 15, and that will give us the maximum value, which is the, this much, minus 9.375. That is the maximum value for B3 equal to B2 equal to B1 equal to B0 equal to 1. That will be 15. That will give us the value which is 15 to base 10. Okay, 1111 to base 10. That will be 15 to base 10, corresponding to the maximum value. Now, in our problem over here, right, step size for 27 kilo ohms. Step size for 27 kilo ohms. So for step size for 27 kilo ohms will be, in place of 20, we have 27. In place of 20, we have 20. In place of this 20 here, we have 27. This remains as it is. Okay, this remains 20K only. Only this remains. This will change to 27. So step size will be now, the what to say, the value of the, V reference. This is V reference divided by the value of 2R divided by the value of 2R. Okay, V reference by 2R, that is 20K, multiplied by RF, right, divided by 2 cube. 2 cube because we have 4 inputs. Okay, 2 to the power of n minus 1. 2 to the power of n minus 1, right? So you can just say, you can write this also. The value, the step size will be, VR multiplied by RF divided by 2 to the power of n into R, where R is 10 kilo ohms, where R is 10 kilo ohms, not 20. Okay, VR multiplied by RF divided by 2 to the power of n, that is 4 bits, n is 4, uh, multiplied by R is 10 kilo ohms. Okay, you can try to write that. So if R is equal to 10 kilo ohms and RF is given as that, so only change is R is 10 kilo ohms now and RF is 27. So we need to write, 5 divided by 16 into 10 multiplied by the value of 27, which is given to us over here. That will be the step size. Okay, that will be the step size, and that has to be multiplied by 15 to get the output voltage over here. Okay, so if you have the calculator, please calculate that. 5 divided by 16 into 100, that will be in the denominator. 5 divided by 16 into 10 multiplied by 27, that will be the value of the output. Okay, that will be the value of the step size multiplied by step size multiplied by 15 will give us the output, and that will be part B. Then we have the advantage. As I said, the weighted resistor DA converter will have, will need resistors of very large range, R by 2, R by 4, R by 8, R by 16, R by 32, R by 64, R by 128, depending upon the size of the number of bits the DA converter is of type. But the R2R ladder network needs only R and 2R resistors. That itself is its advantage. Okay, that itself is the advantage of the R2R network. Fine. So let us go to 8.18. We need to repeat the same thing, only that here RF is equal to 39 kilo ohm. Step size will be now the value, 5 divided by 16 into 10 in the denominator, and multiplied by 39 in place of 27 or 20 in the normal case, we have 39. Okay, 5 divided by 16 into 10 multiplied by 39. That will be the step size. And to that step size, again, you can multiply by 15 to get the value of the output voltage. Okay, so that is what we need to do. So we need to, what we call, determine the step size corresponding to that and multiply. If you want the output voltage, you can multiply with that. Then 8.19, referring to the DA converter of this, determine the output voltage when B0, B1 equal to 5 volt, B2, B3 equal to 0 volts. So how much this will correspond to the binary value and how much it will correspond to the decimal value. With V0 equal to B1 equal to 5 volts and B2 equal to B3 equal to 0 volts, what is the binary value and what is the decimal value? Please put in the chat. Will it be 8? No, I think you written it long back. Fine. So now how much it is? 0011, right? 0011, and that is equal to 3. So step size in this case would be 5 divided by 16 into 10 multiplied by the 39 multiplied by 3 will be the output voltage. Multiplied by 3 will be the output voltage. Then we come to 8.20. 8.20 8.20 is a DA converter of the figure 8.20A with V reference equal to 2 volts, R reference equal to 500 ohms, RF equal to 1.5 kilo ohms, and calculate the output voltage. So let us go to 8.20, which is there in the next figure, might be 356, page number 356. Right, page number 356, you have this 357. Okay, page number 357, you have this formula, right? You have this formula. So you just need to substitute there, right? You just need to substitute there. So V reference 2 volts, R reference 500 ohms, RF 1.5 kilo ohm, right? So you just substitute here, then D7 and all that values are given to you, right? D7 equal to D5 equal to D3 equal to D0 equal to 1. D6 equal to D4 equal to D2 equal to D1 equal to 0. So what will it be? Binary? Binary will be how much? Binary will be 1010. Please write down in the chat box. Please write down in the chat box what will be the binary value corresponding to this. Yes, it will be 8-bit. D7, D5, D3, D0 equal to 1, and D6, D4, D2, D1 equal to 0. So you should write D7, D6, D5, D4, D3, D2, D1, D0 equal to 1010, again 10, then 01. 101010. Okay, there is a little difference here. 101010. I think this has become 9 bits. This middle one should not come there. This one should not come here, right? So the value is 10101001. Okay, the value is this 10101001, right? Right. So this will be the value, and if you convert that into the what you call, please check that. Anjum, you have made a mistake. Okay, so you can just see what it is over here. 10101001. That will be the value, and that value will be the one which has to be converted into the binary number. So how much will it be in the binary? So the weight of this is 2 to the power of 7, 128. The weight of this is 2 to the power of 5, 32. 128 plus 32 plus 8 plus 1. Okay, I think it might be 169. Just check that. Okay, so 128 plus 32 plus 8 plus 1. Okay, whatever is the value. I can't, you just calculate it. 128 plus 32 will become, 160, I think. 160 I think it is 169. Just check that. It is 169, not 149. Okay, it will be 169 only. 2 to the power of 5. For d5 equal to 1, you'll get